Hello everybody, good morning. Welcome to the Second International Conference on Industrial, Mechanical, Electrical and Chemical Engineering. I, Bertha Sopha, with my former student Aries Setiawan, would like to present you one of our research on the network characterizations of good movement in Indonesia. So we would like to present you five sections consist of background, research objective, methodology, result and discussion, and conclusions. So actually, this research has been inspired by the low logistic and performance index by Indonesia, which has been ranked uh, 51 out of 167, which is corresponding to 3 out of 5 skills. And this performance is inferior compared to Singapore, Thailand, Malaysia, and Vietnam. So that implies that we need to do improvement in our logistic costs. And one of the effective way to improve it is by reducing logistic costs, because logistic costs in Indonesia is still higher than the other Asian countries. It is expected by reducing the logistic costs, the industrial competitiveness will be improved. So, given that the transportation cost seems to be the most contributor in the logistic costs, understanding the logistic activities as well as the attempts to characterize the network of good movement in Indonesia is of importance. So therefore, our research objective is try to characterize the network of good movement in Asia, as well as to examine the effectiveness of the analysis for prediction purpose. When it comes to methodology, we use a network analysis using the RStudio software to help us to do the network analysis. And these four parameters consist of connectivity, assortativity, clustering, and centrality is going to be examined to characterize the network. So for doing the network analysis, we use the data from the National Survey of Origin and Destinations, so-called the ATTN, Asal Tujuan Transportasi Nasional, which was conducted by Badan Penelitian dan Pengembangan Kementerian Perhubungan in 2016. So the scope, we use the good movement based on the origin and destinations among the 34 provinces in Indonesia. In order to be able to do the network analysis, we also using other supporting data such as gross domestic products, population data, and geographical coordinates of the provincial capitals as a proxy of the province. So we have 33 good categories as listed in this table, from chemical, coal, etc. until textile. And we use a different code for simplicity during the examinations. So we would like to present you the network profiles that the total value of the aggregate good movement is seen here as almost like 1 million tons per month. And this goods, which accounts for the high proportions, is coal, which is corresponding to almost 50% of the total good movement, while the others, such as mining, contribute the least, which is less than 1% of the total crude movement. So now we come to the results of the network characterizations. We actually use the 34 provinces, but we know that the data is only available for the 33 provinces. Means that one province is not, the data for one province is not available. So we know that the number of ages is about 1000, and the density is 0.94, and the percentage of mutual age is 100%. The higher density means that the province, its nodes is well connected, while the high percentage of mutual age represents that the relationship is reciprocal between the nodes of the province. However, the average path length is 1, which is very small. So it implies that given that the high network density and the high percentage of the mutual age, which is corresponding to relatively low the average path length, implies that the good movement is dominated by the point-to-point movement. So it means that the goods is delivered from one province to another province, and the movement does not require the presence of a mediator, or we call it as a hub. So based on the connectivity analysis, so we use the connectivity as represents of the relative degree of connectedness among the provinces, which were measured by the node degree and the node strength. So we abbreviate it using ND and NS. So based on the result on the table, we see that most of the provinces have been connected with all other provinces. As we know that the node degree is almost near to 33. And while only a small number of provinces are connected with few others. But the good movement between the provinces is dominated by weak relationship. Only just few of them has a strong relationship. So as we know now that actually this result is consistent with the previous one, that shows that the good movement is dominated by point-to-point movement or point-to-point system, while the relationship is weak. So when it comes to assortativity, which represents to what extent the province associate with other province in the network, being similar sort or being opposite sort, and the negative correlation indicates that the network is disassortative. So as we see from the result that the network shows a weak disassortative, given that the negative values or some values, although this is a very weak. So it means that the province that high connectivity, or we call it the high NS values, will tend to carry out goods movement activities with the province with have low connectivity. So when it comes to clustering, so we use the clustering coefficients to represent the degree to which a province tends to make a clusters or a group. It means that the highest value of CCs indicates that the network is weakly clustered, and on the other hand, the high value of CC indicates that the network is strongly clustered. As from the table, we know that the value of the CC almost to 0 means that the province has low frequency in forming clusters. Further investigations on each of the value of the CZ for each province, we found that a province with high goods movement has a high level of interconnections with other provinces. Means that the positive and the high correlation value indicates that the network has a rich club phenomenon, which implies or which represents that the province with high goods movement tend to group with other provinces with high goods. And when it comes to centrality, usually used to indicate the most important province in the network, we saw from the figure that the graph is y-skewed and thin-shaped, which means that only a few provinces which have high centrality. But actually, this result is supported by the previous finding, which shows that the network performs a core-periphery structure. That means that the existence of the core-periphery structure implies that some provinces may have a role as hub or as a core, while the others are as periphery or support or spokes. So then, based on the result of the network analysis, once we already parameterized the network and we got the parameter values of the network, and we would like to use it to for prediction models, and in order to be able to evaluate which one is better, we use the other models which was based on the gravity models parameters. So those 33 good categories are evaluated by both using gravity model parameters and the characterized parameters, and we saw that here in the figure the present variance explains for each of the good categories. So based on the graph, particularly in the orange line, which shows the characterized parameters, seems that it performs better than the model which are developed using the gravity model parameters. And quantitatively, that the average percent variance explained by the characterized parameters is 39%, while for gravity model parameters is only 30%. It means that using the parameters based on the network analysis, the prediction models could be performed better. And in some good categories, even that the variance explained is more than 60%, such as for the good categories of chemicals, fuel, meat, and livestock, fuel, fish, crude oil, and fertilizers. So to conclude our findings, that we found that the network of the good movement in Indonesia is characterized by weak inter-provincial good movement. So there are good movement within the province, but the relationship is weak, and the network is characterized by scale-free network because some of the province may act as hubs while the other acts as spokes by following the provincial attachment. The network also shows some disassortative, means that the high intensity of good movement, the province with high intensity of good movement tend to establish the relationship with other provinces with low intensity of good movement. And also we found that the phenomenon of rich club phenomenon exists, where the province with high strength will tend to be clustered with the province with high strength, such as the Sumatera Barat and Jawa Barat, which act as a core of the network. And secondly, using the parameters based on the network analysis could perform better for predictions of a good movement than using other methods such as gravity models. And even though, uh, and moreover, some of the good categories can be very good predicted by the characterized network because it can explain more than 60% of the variance. However, it's very important to note that the network characterization that we have conducted is based on under normal conditions, of course by other disruptions such as now that we have been experiencing the COVID-19 pandemic, the network could be disrupted, and it is very important to characterize the network during the disruptions. So therefore, we could like to investigate further on the resilience of the network, and that we would like to propose as a future research. So with that, we would like to conclude our presentations with thank you very much, and we welcome to any questions. Thank you.